Without any further ado, let's welcome our speaker, Kumar Anirudha. He is a developer advocate at IOTA Foundation. He's also a co-founder of Acyclic Labs, where he builds decentralized infrastructure platforms and applications. He has also worked with multiple startups in the past in various developer, architect, and product roles. Most importantly, he started an open innovation community on blockchain. Blockchain India to develop and talk about blockchain and DLT. He has been one of the steering community members of IOTA Evangelist Network. Over to you.
Hello, everyone. Thank you for the Women Who Code Blockchain community for this opportunity and for arranging this and forward interacting with everyone. So we'll just get started with the session. But if you have, I think, any questions, you can directly put it up on the chat, the Q&A box over here, and we'll take it up one by one. If I miss out, please do call out, and you can take it up. So, if whoever is interested in sharing, how many of you are developers over here, and how many are coming from a non-tech background? Just so I can curate accordingly. If you want to, please put it up on the chat box while we continue, and we'll get to it. So today's topic is IOTA Tangle. For those who are aware of, are not aware of it, IOTA is another cryptocurrency, and Tangle is the DLT network on which the entire IOTA ecosystem is built, and different apps built on top of Tangle. So we'll dig into what exactly is Tangle, why is it, and how is it different from blockchain, and what advantages it brings, what disadvantages does it bring, and what can you do with it? Where can you find, how can you build applications over it? How to get started building applications over it? And where we are heading towards. There's a lot of active developments going on, some of which I am allowed to share, some of which is already public knowledge. So we'll only deal with whatever is already launched, and we will keep the discussion to that point. What is IOTA? IOTA is a cryptocurrency, and you can find it as MyOTA or something. I think it's for, I was first introduced to IOTA back in 2017 when I started exploring various different types of DLTs, which we'll jump into in a moment. So I think I was introduced to well enough, but let me just quickly reiterate. I'm a developer advocate at IOTA Foundation, and I also take care of tech and ecosystem at Assembly. Assembly is we'll actually dig into Assembly as well. Assembly is another project that is coming out of IOTA Foundation, and it's a cross-chain multi-network, which is a layer 2 on top of the IOTA Tangle. So don't get confused. We will deal with what exactly is, we'll understand what exactly is layer 1 and layer 2 and all that as well. Apart from that, I've run multiple communities, and prior to that, I also was working on product side of things and blockchain community in general. So first, when we think about blockchain in general, the first thing that we learn about is DLT, decentralized ledger technologies. Now, when Bitcoin blockchain came into being, it came as a singular, as only the blockchain part. But then enterprises, some enterprises came in and they said that, you know what, this doesn't cater to our exact needs, and we need a more permissioned way to, or a more governed way to operate our own blockchain. So then they made a smaller section of a blockchain and call it permission blockchains. But there are certain ledgers which does not fall exactly under blockchain, but they still, follow a lot of the rules of what a DLT is. And IOTA Tangle sort of falls somewhere under in this area. So it's not exactly what you would call a blockchain, but it's different from that. And we will learn how it is different. There's also a very broader category with distributed databases, with I think a lot of you would have already been working with it since I think 90s or 2000s, right? We were working with Cassandra distributed databases, even normal distributed databases. We would share it and replicate it so that we can work on it. And then there would be like some private setups, which later on get synced to the main database and thereby distributing the data in that respect. In recent years, I think if you have heard of Blockchain DB, that falls somewhere in distributed database. It's not exactly again Blockchain DB. You can't consider it as a DLT, but it's a database which is purely distributed. Of course, it's an immutable distributed database, but that's a different term altogether. But it's very important to understand that the differences between a distributed database, a DLT, and a blockchain. So just to make that clear before we get started. So when blockchain came into being, it's very easy to understand what exactly blockchain is. You just start with a genesis block, and then you keep adding one block after the another, and over time it forms a chain of blocks, which essentially is blockchain. And that's where Bitcoin started, right? As a decentralized distributed network, and as more and more transactions were happening on this Bitcoin blockchain, it became bigger and bigger. Slowly, there were other blockchains which came into which came into our ecosystem, like Ethereum. There was Peercoin, Litecoin, and then I think currently there's more than 20,000 tokens registered on CoinMarketCap itself. There might be even more cryptocurrencies out there. So every cryptocurrency doesn't necessarily need to have its own blockchain. That is because of how Ethereum came into being. But earlier, every cryptocurrency there needs to be a native token for every blockchain, which would govern of how the validators or the miners are rewarded for the work they are doing for the network. By work, I mean for maintaining the network, for validating the transactions that's coming into the network, and so on, right? And so, when all of these different chains started getting formed together, they distributed the data as well. So all of these different nodes has the same data in all of these nodes, and that exactly became like the blockchain. So inherently, what will happen is if one or two of these nodes go down, the entire network is still not down. It can still operate, and while these nodes come back online, it can still operate with the rest of the nodes until and unless majority of the nodes are up and running. Of course, if the majority of the nodes goes down, then the entire network is down in this scenario. So it's very important that this network is decentralized and not all are running on the same by the same organization or controlled by the same set of servers. So at some point, if, for example, AWS goes down, the entire network shouldn't go down, right? That's the entire concept of how blockchain needs to be decentralized and distributed. But if you want to understand what exactly are the building blocks of a blockchain, it requires 4 different things. One is consensus, a programmable interface, which we call as smart contracts, which got introduced with Ethereum blockchain, a distributed database, and a decentralized network, right? So based on these 4, by consensus, I mean all the nodes need to agree on what exactly is the data that needs to go on the chain. And programmable interface smart contracts is the way to do it. Like you can actually program, you can actually write a program and put it up on the blockchain and let others also use your smart contract. Distributed database, of course, means that every node will have its own record of all the transactions, the database itself, and a decentralized network. No one server is, or nobody is actually controlling that network. Based on these four, we can actually distinguish blockchain into these four categories. It can be public permissionless, which is Bitcoin, Ethereum, and so on. It can be public permission. It can be private permissionless, or it can be private permission. Now, this is obviously, highly private, and it is easily debatable that it doesn't really mean that it's a blockchain. But again, it's highly debatable. A blockchain can also be public permission, which means that everybody can read it, but only a few authorized validators can write data to it. It can be private permissionless, which is very rare, I would say, but it would be that there is a use case in the enterprise sector as well. So you can distinguish blockchain into these four categories based on these four different building blocks, right? Now, over time, we have seen some apparent bottlenecks in blockchain because as the network started growing, more and more people started using this network. We started seeing that the confirmation started getting delayed. It started slowing down. The entire network started slowing down. The gas fee, the miner fee, started increasing because obviously, if I have to now confirm, let's say, if my node has to let's say confirm 50,000 transactions instead of 5, I would obviously start charging more. That, you know what, they start making it expensive so that not a lot of people spam this network, right? So, and of late we have seen this. Actually, not even off late. It's back in 2017 onwards. We have started seeing expensive fees, like really expensive fee. 2016, 2017, we started seeing very expensive fee, gas fee of blockchains. I remember in 2017 when ICOs were, a thing. Today NFTs are a thing, and that has led to huge transaction fees and gas fee. And of course, slow confirmations of the layer 1 networks is just crazy. I think Ethereum does something around 15 to 25 transactions per second, which is incredibly slow. Of course, Ethereum is coming up with a POS safe system, but that's another story. We will see how that turns out. But yeah, these are some of the apparent limitations that we have started seeing in blockchain now. So thereby, Tangle came up with their own system, which we call as DAG, or directed acyclic graph. So we will, and the idea was to solve these issues that blockchain is facing. Now, what Tangle tried to solve was to have a highly scalable system to make the transaction, as low fees as possible, and ultimately they made it 0 fee, which was revolutionary from the time it was introduced. Quantum immune, given the consensus algorithms that was used at the time, and of course, secure data transfer throughout the network, right? And all this was possible because of the architecture that the Tangle network chose to go with. So the architecture of the network, it's derived from something called as directed acyclic graph, or DAG. What DAG means is that it's not a linear chain, it's like a graph, and so there can be multiple leaf nodes to it. So you can think of in that respect, right? And so it doesn't need to, attach, like the new blocks doesn't need to attach to a single point of entry. It can just enter at, multiple points, and it can keep on growing from from that particular 1 point to 2 and then 3 and 4 and 8 and so on, and it can keep on growing in that respect. So essentially, the more these transactions will come in, the network will grow at a much faster rate, right? So what is mentioned by first and second generation is that Bitcoin can be considered as the first generation, where it only allowed the currency exchange to happen. Ethereum introduced smart contracts that can be termed as second generation, and we can term third generation as Tangle, which is going a little bit away from the concept of blockchains and going into a DAG-based concept. And with this, you can also eliminate, so the idea is that there is no central or there is no specified miners or validators in this case. So if I want my transaction to be accepted onto the Tangle, I need to confirm or validate 2 more transactions that is coming up on this chain. So as soon as somebody else, confirms my transaction is there. Now I have to sit there and I have to wait for 2 more transactions to come in. I have to confirm those 2 transactions for my transaction to be safely included in the chain, in the network. Sorry, and this idea is obviously works extremely well when there are more and more transactions coming in, because then the network can confirm transactions at a much faster rate. So the more transactions come in, the faster the network grows. But of course, if there are less number of transactions, then this becomes sort of like an issue, because now my transaction is just sitting there and there is no other transactions to confirm. So even though my transaction is confirmed, it's still not accepted in the chain. It's still one of these gray nodes, as you can see. And it will still sit there till there are more transactions to confirm, and only then it will move on to this green zone, so to say. So for that reason, and also Tangle can also, you can also separate it out into a private Tangle and work in seclusion, and at some point you can just include the entire thing into the main onto the main Tangle. But in that case, what would happen is the entire chain would just, if it's a big enough private network that you're attaching at one point, it will just grow into that direction. That poses a different issue, right? So to solve these certain path and direction related issues, Tangle introduced something called as codicil, which is like a coordinated node. So that makes it slightly permission. Of course, we will come back and how we are sort of tackling the situation right now. But yeah, that is what Tangle came up with earlier. So essentially, because there is no miners in the system, Tangle becomes a completely feeless network, right? And you can doesn't matter how many transactions you go on to, it doesn't matter how many how many data you exchange, how many messages you send, your network, the gas fee or the network fee is still at 0, so you can send a lot of networks. This also obviously encourages a lot of spams that comes up, and of course that's the general idea of it, right? And so if you can see this diagram, you will see that the more the number of transactions come in a blockchain system, it will only get accepted one by one into this particular chain. But in case of Tangle, the neck literally expands as more and more transactions are there, because now it will have more transactions to confirm from the end perspective, right? So that's the bottleneck that blockchain and that the blockchain's consensus has, that Tangle solves, right? So the more activity there is, the more validations there will be, and that's what the general idea of Tangle comes from. So essentially, at least theoretically, the more it gets used, the Tangle will keep scaling up, and a blockchain will scale down. It will become slower, and while Tangle becomes faster. Of course, we have seen this in action as well, but we are now changing a lot of the architecture, the underlying architecture of Tangle as well. So we'll come back to it at the same time. But yeah, this is what IOTA Tangle is, and the current mainnet also is based on this. So, any questions so far? I'll just take a quick questions till this point, and then we will move on to the next generation of what we are looking forward towards. IOTA is a protocol or a token. IOTA is a token, and the Tangle is the protocol. Okay. Okay, I see there's no more questions. If there are, what if?
I guess anyone has raised their hand.
Oh, okay. What if you need to wait? What if you need to wait? You need to wait for new transactions to come in. In that case, in the current scenario, it will, like, that's the idea with making it, zero fee, so that there are more and more spam transactions coming in, and there are certain products which the only purpose of which is to spam the network so that more transactions come in, and it just gets accepted, which is, of course, if you ask me, it might be a little hacky way to do it, but that problem is also getting resolved in the next version. I think if that was your question, or if you want to.
Prachi has asked in the how can it be overcome?
Right. So we'll come into that in the next section, and which I will talk about IOTA 2.0. Any questions so far? Any other questions so far?
Not right now.
All right. So we'll proceed. All right. So IOTA 2.0, the major problem that the crypto community obviously had, and also with IOTA's own Tangle network, was this coordinated node, right? Because it's very permission, and it didn't allow. It was obviously governed by IOTA Foundation, and it is a nonprofit organization, but still, it's not very widely accepted if you're operating a very public network, and it's not very open from that perspective. So with IOTA 2.0, the entire architecture went through a revamp since 2020. The work has been going on, and now we are almost at the completion stage of IOTA 2.0 with the new consensus and new transaction system and everything. So we're going to launch pretty soon, and with it comes a lot more other things that IOTA Foundation has been working on over the last few years, which I'm going to talk about as well. The first thing is the new consensus. It allows for auto peering and Tangle access, which solves some of the, now it's not completely feeless anymore in a way. So we have introduced a concept called mana. Now, it's very important to understand why exactly is fee required in a blockchain network at all? Like, if everybody just, we can just pledge that, or all right, we'll just, operate this network free of cost and so on, like what people did with internet back then, right? But then it wouldn't become the type of network that we want to work with. Like internet was supposed to make it everything open. It was supposed to democratize. So it didn't really do that. It gave a lot of power to a few selected organizations, which have operated that since then. If we want to have a completely open network, there is obviously need to incentivize even the smallest of contributors to that network, and that's what gas fee does. In this case, with Tangle, we have introduced a concept called mana, which is like every node will have, which is, I think, I believe it will operate very similar to what you will you can relate to from a POS-based system, proof of stake. So a mana will tell us what is the status of this particular node, how good is this node in this particular network, or how bad is this node in this particular network. So the more mana a particular node has, its voice will be heard a little bit more. The least, if your node's mana is very, very less, you might not even be able to, send transactions to this network. And at this point, the idea is to make it purely decentralized. So the problem with, not enough new transactions coming in, or the coordinator going off, now entirely goes away with this new consensus, and that's the entire reason mana is introduced. Mana is still not the transaction fee, by the way. There's slight difference from what these two are. So essentially, there will be some transaction fees, but that will always still be lower than what you will have on a blockchain network, any blockchain L1 network for that matter. Perhaps you can compare some proof of stake based networks, but otherwise any other network you can still consider that the fee will be extremely less. And some new concept with auto peering has been introduced, which is like any new node which is now introduced onto this network can get connected with its neighbor directly, which is already there in our blockchain-based system, but in Tangle it was not there. We had to connect with neighbors by ourselves, and then auto peering was introduced later on. The base layer itself, we are introducing that. And the new consensus is called fast probabilistic consensus, or FPC. Now, the votes in FPC are weighted by the consensus mana. So no attacker can actually, manipulate this outcome. And if, say, now another question rises that if, for example, some supposedly good node is not exactly a good node, right? They have very high mana, and now they start acting out of their own interest, and they try to confirm some illegitimate transactions. Now what happens? So yeah, they may be able to do one or two at the very beginning, but then as soon as the other nodes which are also in the network, which might have similar high mana, they might start getting conflicts. They will be punished for that for their wrongdoing, and they will just go down, and so they will become something like these pink or red nodes, whatever you can see on your screen, which the transactions of which will not get confirmed anymore, right? And this consensus mana will be used to also compute the finality of the message, right? And this will be weighted by the mana of the nodes. So a good analogy would be that if 5 good people refer you to a company versus 10 completely unknown people refer you to that same company, you're more likely to get accepted if the 5 known good people who are referring you. So you will always want to go via the highly reputed mana nodes always. So this also puts a lot of pressure on nodes which would want to at some point do something wrong, but they would still be scared that they might just get banned out of the network altogether. And it would take a lot of time after a certain point to build up that level of mana to again reach to that stage, right? Obviously, nodes which are joining at the very initial stage of the network will have a really high mana, but again, high risk, high reward. They might also get slashed all the more towards the very beginning, and towards the end, it might, if they join later, they will get lesser rewards, but they will also get lesser negativity if they fall under some suspicious activity or anything as such, or some contest of that matter. So again, if you're interested, there's a very nice article about FPC, the fast probabilistic consensus, which has been published, and there are some updates coming up as well. So Feel free to go through blog.iota.org, where there's a lot of such articles, and there's a lot of research material as well available, which I think would be very interesting to read upon as well. Now, there is a secondary usage of this mana, which we'll come back when we talk about assembly, but we'll go ahead for now. And with that, we can introduce something, we can introduce IOTA smart contracts. Now, running smart contracts on L1 is very, very costly, as we have already seen in Ethereum. So, networks like Polygon as a sidechain has come up, then now different sorts of L2s are coming up with, rollups and all that, which will help in reducing, one, scaling the L1 network, and second, obviously, lowering the fee that is required to run such a smart contract. With that in mind, IOTA smart contracts will run on a layer 2, which is like the Tangle is still the layer 1, but there will be a layer 2 now on which IOTA smart contracts will run. It will run on something called as the WASP nodes. So if you're interested, the project is also open source. Feel free to go and check it out on the IOTA ledger/WASP GitHub, and you will find that. Now, this brings a flexibility of IOTA smart contracts to IOTA ecosystem, which till now it was not there. So IOTA smart contracts beta went live on the test net last year, November, I suppose. Either it was October or November, sometime around that. But yeah, since then we have been testing around our smart contracts, and it's still now it's on the layer 2, but all the state transactions are obviously anchored on to the L1, which is the IOTA Tangle. This obviously offers a lot of advantages, which we will talk about as well. But one of the major things is that now you can run actual chains on layer 1 and still have all the advantages that Tangle offers with its consensus and its feeless nature and everything, right? So while the main transactions remain feeless or the least possible fee possible, your IOTA smart contracts can still have, like, you can set up your own nodes and you can charge a fee for it to your users if you want. This is a couple of months old, so there were a lot of changes added to it. Right. So the first thing is it right now supports multiple languages that you can write smart contracts on. You can write it on Solidity, which is the Ethereum's smart contracts language. You can write it on Rust or Go, Tiny Go in that, for that matter. And there are more languages which coming up now. There has been TypeScript added as well. There are multiple virtual machines that is available, including Ethereum virtual machine and the WASM VM, which is the WebAssembly virtual machine. We'll talk about that as well. And the important part is that since it is a layer 2, and you can set up your own set of private committee on this layer 2, so you can essentially set your own gas fee if you want to bear all the setup cost and everything on yourself. You can make it 0, and your users will not have to pay any gas fee to operate on your network. And you can offer that as a service as well. Or if you're connected with the public network, they might have some sort of fee, or maybe a low fee or something. You can even increase the fee in your own private committee if you're doing something really, really that you don't want a lot of people to interact with, while also want to maintain the public structure of it. And yeah, validation incentives. So every fees that it can be paid in IOTA tokens, which is the L1 token, and you can also set up your own tokens on L2, and you can have that conversion set up that is completely according to you. And yeah, of course, all the advantages of smart contracts come into being. So you can set up your own, you can write any smart contract that you possibly can imagine, and that will run on this network. Now, if you look at the architecture very closely, this is the by UTXO layer is the transaction or for the L1 layer, and the ICP chain, which is the IOTA smart contracts protocol chains, is the layer 2. In this case, there are multiple chains that you can see, and there are multiple smart contracts that are deployed on every chain. Each chain here is equivalent to a blockchain. So it's equivalent to an Ethereum blockchain. You can imagine that. So you have like multiple Ethereum, multiple blockchains on L2, and they are connected. So you can have a multi-chain architecture on L2 itself, and you can control all of it. Of course, you can, if you want to connect that to some external network like Polygon or Ethereum right now, or Avalanche or something else. For that, you would need bridges, and as such, something which Chainlink and other protocols provide. So you can either integrate those, or I think with Assembly will be anyway integrating, so you'll be able to get that. But the advantages that you'll get in this multi-chain architecture is that you can have your own chain. You can deploy the smart contracts, and you can interact with a smart contract that is deployed on a different chain altogether. So if you even want to, separate out different projects of yours with different chains, and you want some project of some smart contract in one chain to interact with another smart contract in some other chain, you can actually do that in this entire L2 architecture, and that's not available in any other network right now. A little bit similarity with is there with the Cosmos ecosystem, but there's still a lot of differences with the shared security aspect as compared to the interchain security. But let's not get into security right now. The smart contract languages supported are with Rust, Go, TypeScript, or JavaScript. If you know TypeScript, then it's really lucky for you, because you can write your smart contracts in TypeScript as well. You can write your client libraries and there's a client library available in TypeScript as well. So you can just write everything can remain in the the JS ecosystem. However, if you are more aware of or more used to Go or Rust, you can write in those languages as well. We have also a schema tool which will allow you to easily generate smart contracts using that in each of these three languages. And finally, Solidity. Solidity, I think you might already be aware of Solidity from Ethereum ecosystem, and which will run on any EVM out there, right? And there's already lots of resources out there for Solidity, which you can use and learn from. And these three languages are compiled by something called as WASM, or WebAssembly, which is another really interesting aspect of our smart contracts ecosystem right now, because most of the smart contract protocols right now are moving towards a WebAssembly, WebAssembly or WASM-based system. Even if you know this platform called OpenSea, right? I'm sure a lot of you have heard about that. OpenSea have recently also moved to their new protocol, which is Seaport, and which uses actually WASM to lower, and from their article itself, I think they mentioned it will save millions of dollars from users. So that's pretty huge. How does it do that actually? So WebAssembly compiles it into WASM, your Rust code. Actually, I think it works with C++ and Python as well. But for now, we only support Rust, Go, and TypeScript. So anything that you can, and if you want to contribute to it, and say, for example, you are more used to Python or C++ and you want to integrate that language, you can actually contribute to that and add to it. So anything that you compile once to WASM and then you deploy it. So it generates a very low footprint, and it becomes, and thereby it will consume a lot less transaction fee for you to operate your smart contracts on, and you can deploy it using that. Now, IOTA smart contracts supports WASM, and the WASM VM runs for that. So how does that work? It uses something called as WASM lib, and it will compile it from there. So every smart contract will will be combined using the wasm lib and will be deployed to it. Right now, I think we are using wasm time, which have started supporting, I think, most platforms. And up until a few months ago, I think the GitHub Actions didn't support the ARM-based chips, or which is the Mac M1s, but now they have added that as well the last couple of months. So I think we are good in every native system that there is out there, right? And once it is compiled, it again gets it, like the IOTA smart contracts protocol itself. It will read it read the same way, and similarly will the EVM also operate. Like the EVM, you can also deploy it on top of this, like as a third layer over here, and that will also operate in the same way via the ISCP protocol itself. So you can essentially deploy a WASP node, a WASP chain over it, which was here, right? So this is a WASP. So imagine there is a WASP node, and on which you are deploying different WASP chains, right? In each of these WASP chains, you can compile, every WASP, every WASM-based smart contracts, and you're deploying it. And the state, the change state of it is, let's say, been set, and it will be pushed to the UTXO layer later on. You can have as many WASP nodes as you want. Possibly, if you want multiple WASP nodes to deploy, you can do that. Each of these WASP nodes you can form into a committee and form a committee itself. You will have your own validator committee. And on each of these WASP nodes, you can deploy as many WASP chains as you want. In each of these WASP chains, you can deploy as many smart contracts as you want. You can even deploy an EVM chain on top of a WASP chain, and you can operate from there. So essentially, this is an entire ecosystem that we are, that as IOTA smart contracts is providing at this point, and it can scale beyond what we can think of right now. Hopefully, there will be proper usage of it going forward, and we will see how more and more people will get used to it. All right, let me take some time and talk a little bit about SHIMMER. SHIMMER is as the slide says, is the next step in IOTA's evolution. SHIMMER is a staging network, which is right now in the alpha stage, and it's under development, and it will be released soon, obviously. But what it will provide is that you can actually, once you've developed your application, you can deploy it on SHIMMER and give it to real users with using the SHIMMER tokens, and you can check it out like a staging network, and let your users and let everyone try it out, try your app in real world scenario and see how it operates. There will be actual bridges built out from the SHIMMER network to other networks as well, so you can also operate it from there. And yeah, it is very customizable, and you can actually choose, like this particular triangle says. It's very difficult to actually solve this triangle if if you have seen this before. You can obviously, select either security decentralization, security decentralization, or security or scalability. But either of any of these, whichever you once select, SHIMMER can operate in that perspective. In that perspective, but there are a lot of features which is coming up in SHIMMER, which we will eventually release slowly, and then we can talk about that. But I just wanted to introduce SHIMMER a little bit. And finally, I want to talk about assembly. Assembly, now, we just talked about the IOTA smart contracts layer 2, right? Now, the public network of that is what assembly will be. So you can imagine assembly as a huge committee which comprises of a lot of WASP nodes. Each of these WASP nodes will contain a lot of WASP chains and EVM chains. And that is this public network, permissionless public network, multi-chain network is what is assembly. And right now, assembly is not launched yet, obviously. But what is launched is IOTA smart contracts. So if you want to build your application out of smart contracts, once it starts working with that, once assembly is launched, you can directly launch it on assembly, as well. And assembly will anchor onto the layer one IOTA, which is the Tangle itself. So not to confuse assembly with SHIMMER, these are two different projects. And SHIMMER will be the staging, whereas IOTA plus assembly will be a separate thing altogether. So to develop with IOTA, there's a lot of projects in IOTA which I couldn't talk today because obviously I want to focus on the Tangle itself. But there are a lot of libraries out there. There's the smart contracts, which is the WASP node. With Codify Library 2.0, there's the Codicide specs and Go SHIMMER node. So right now, the master branch of WASP repository works on top of Go SHIMMER, but the AlphaNet version is soon, which is on the develop branch, is working with the Hornet node or the L1 node. So B and Hornet are used to run the L1 or the mainnet of IOTA. You can also read Chrysalis doc, and there are some integration services with streams and identity projects. Identity is the decentralized identity framework, the decentralized identity protocol of IOTAs. Streams is a data layer which is used to share data amongst everybody, and it's actually pretty cool. You can essentially develop social media app using just streams, or I remember integrating streams into a IoT project in which the Raspberry Pi was talking with a remote server, and we were sharing data. The entire data can be shared using streams. And yeah, let's feel free to go through all of these projects and see if you have, and if you want to use one or more of these. There's also the wallet app, which is the Firefly app, which I've not shared. And Stronghold is the secret manager, or the ones that handles all the secrets of yours, or basically the wallet addresses, your seed and everything. And how do you get started with developing on IOTA? So obviously, first you can get started by from the IOTA wiki, iota.wiki.org, and you can start developing on your local system wherever you develop. However, if you have any questions, feel free to ask. Go on discord.iota.org, always available there. And once you have done that, once you have built it, you can distribute the community on SHIMMER network, which will soon be live. And once you feel you're comfortable with that, you can also go live with assembly, which will go live after SHIMMER. And that's the stages in that. And you can take advantage of the feeless multi-chain network that assembly will be. With that, I come to an end of this talk, and I think we have a few more minutes. So if you have any questions, feel free to put it up here. Or you can, I guess, unmute and ask, whichever you prefer.
There is a shout out from Nisha. Great session.
Thank you, Nisha. Thank you for joining. Any questions or any unanswered questions that was from earlier? How does the multi-chain communicate with each other? All right. So that's a very good question. And actually, it's in the protocol itself. There is some core contracts via which it can operate. So every smart contract that is deployed has a particular address, right? And every node will have also a particular address. You can use those to find that in the multi-chain environment and reach that smart contract and get a value from that, or send some value to it, trigger another smart contract for that matter, and so on. There is also a very interesting question which comes up when operating in a multi-chain environment with different smart contracts. For example, say my smart contract wants to perform a function. That function depends on another smart contract's function's response. So if I, for example, run this particular function, and it's say evaluated small something. And then I go back to that smart contract, and that operated something, and that generated a particular result. So that particular result is now will be put up also on the it will also save the state of that particular of that particular response, right? And then it will return that to this function, and this function will try to evaluate. And for some reason, if this function, doesn't evaluate or just fails, what will happen to that particular state? So in that case, what has been done is that this entire thing will be part of one particular state change, and that state will not be changed until the entire loop is closed. And so that will wait for this both and the acknowledgement from the from the entire chain to close, and then only that state update will also happen. But yeah, every function will have its own, every WASP node. You can find that in the multi-chain, and you can call it from there. It's basically like how you would how your home address is found, in, let's say, a big society or something, I guess, if that analogy helps. Do we have any portal to try and web this IOTA like Ethereum? Yeah, there is actually, like, so you can just so if you mean like to try out IOTA, do you mean something like browser ID or something where you can just click and it will work? Or do you mean to, let's say, transfer some tokens like Remix? Okay. Yeah, like Remix, I guess there is not like Remix, but Remix can work on the IOTA smart contracts EVM chain now, right? So the IOTA smart contracts, if you go to iota.wiki.org, there will be, I might be able to show you, just a second. So you can just go here and you'll find actually that there's some testnet here. So you can find out these EVM, yeah. So you can find these URLs, and you can connect your MetaMask to this JSON RPC to this JSON RPC endpoint, and you can use Remix as well. This will work perfectly fine with that. The Explorer is at this place. Of course, this is a test net, so don't use like, okay, I'll just share the link in the chat, so everyone. All right. So yeah, I mean, don't use it for any actual data or actual purposes. Just use it for testing, because it's a test net, so it gets reset every now and then as soon as a new breaking change comes in, which happens very often because a lot of changes are happening these days, and will happen as well. So it gets reset every now and then. But yeah, this is current Explorer. The Explorer is also going to undergo some changes. There is no online IDE at this point. So, but then we have, I mean, some examples over here. So you can try out, creating. All right. So this is an example which I wrote for ERC721. So you can create an NFT smart contract and deploy it using Remix, a step-by-step guide. There's another one in which my colleague created this for for ERC20, so you can write your own tokens. For WASM VM, if you want, you can there's actually schema tool in which you can create a Rust smart contract or a Go smart contract, and you can go from there. I personally prefer Rust, but if you are more comfortable in Go, then you can do that. Or yeah, of course, TypeScript is there. So if you are from the JS ecosystem, I think that will be. Oh yeah, there's some video tutorials as well. So I hope these will help you out. And if you want to set up a node, you can also do that. There's running a node as well here. Of course, these will also, like I said, these documents will also undergo some changes, some updates, because because we are moving away from the SHIMMER-based network to the IOTA L1 network for IC, the IOTA smart contracts, for the IOTA smart contracts. But yeah, I think this will be good enough if you want to get started right now. And yeah, feel free to ask any questions that you have on Discord, available there at most of them part of the day. So, or there's other folks in the community who would be more than happy to help you out. Can you tell us how to get started with IOTA development tools? All right, yeah, yeah. I mean, again, I'll just point it to the wiki and to Discord and to this particular section. So there are client libraries which obviously you can get started with if you're aware of Code.js. So there's various operations that you can do, like creating address and sending a message and so on. If you're aware of MQTT or something, you can even send a message using that. There's wallet libraries and identity and streams. So all of these, feel free to just go through the entire wiki. There's tons of stuff over here, and we're coming up with more things to make this really simple and easy. There's also an example project of a smart contract. It's a fair roulette. So let the gambler inside of you awaken, and you can play. You can even deploy your own fair roulette game and play it with your friends or something. It had a So there's a front end part to it, and there's a backend and the smart contracts part to it. Both are mentioned in this document. The easiest way to actually run a node is the pre-configured development Docker setup. So this will just, you just have to configure a couple of things and the node will get it up and running. IOTA plays blockchain and IoT. So initially, IOTA was, because of its low footprint, actually you can, and because it doesn't require a minor setup, you can actually run an IOTA node on a Raspberry Pi, which I did. And there's actually a project as well, which does that. Raspberry Hive. raspberryhive.com, I guess. No, .org. I forgot what URL that was. Anyway, okay, we'll find that out. But yeah, as we have a project which provides an interface to setting up a node on Raspberry Pi itself, or you can just run a Hornet or B node on Raspberry Pi, just to the other nodes. And apart from that, right now with their smart contracts, it's the large ecosystem and lots of other use cases also open up. So looking forward to more feedback and suggestions on what all, and would love to know what everybody comes up and works on it, so that it can probably help you better or build more tools around it. Any other questions?
I guess there are no other questions, Anirudha. Thank you for having the session. You can add yourself on the blockchain community, and you can even ask the questions there. You will find a channel called Event Recordings. You will find this session recording there as well.
No, thanks for joining, and thanks for having me.
Thank you. Pleasure is all ours. Thank you, everyone, for joining this session.